When automotive engineers first heard about Tesla's plans, many of them simply dismissed them. One press instead of hundreds of welded components? Impossible. But whilst competitors were shaking their heads in skepticism, Tesla was quietly rewriting the rules of automotive manufacturing, and by the time the industry realized it, there was almost no one left to catch up with. And now the company is preparing to take its next step, one so radical that even those who had already accepted the Giga press as the new norm found themselves caught off guard once again. By the end of 2025, Tesla's production line in Fremont was operating with more than 1,000 robotic arms for welding, painting, and assembly. A high-tech factory in every sense of the word, or so it seemed, but in early 2026, Tesla removed half of those robots from the line, not because production had been scaled back, but because something fundamentally different had taken their place. Elon Musk said it plainly: Tesla now has a vehicle manufacturing system unlike anything else in the world. And at the heart of that system is the fourth-generation Giga press, a machine that Musk had spent years developing specifically for new models, including the Cybercab robotaxi, a machine with the greatest casting capacity ever created, operating at a speed more reminiscent of consumer electronics assembly than a traditional automotive plant. But a reasonable question arises here. Why do you need an even larger press when the new vehicles are compact? What's the logic? To understand that, you need to go back to the very beginning. The story of the Giga press has its roots in the development of the Model Y. Tesla had an idea: remove hundreds of welded components and replace them with a single massive aluminum casting. The problem was that a machine capable of doing this simply didn't exist. Musk approached leading manufacturers of casting equipment from around the world. No one could offer what was needed. No one except an Italian manufacturer by the name of Idra, which at that moment happened to be finishing development of a giant high-pressure press. The timing of that coincidence proved decisive. And so the Giga press was born, the machine that today produces the largest structural components for models such as the Model Y and the Cybertruck. The process works as follows. An aluminum alloy is melted in an enormous furnace at extremely high temperatures. The liquid metal is then injected under colossal pressure into a steel die that reproduces the exact geometry of the part. The pressure forces the molten metal into every microscopic corner of the die, eliminating voids, weak spots, and defects. Once the die is filled, cooling begins. And this is where the entire technological significance lies. If the metal is injected too quickly, air bubbles form inside and weaken the part. Too slowly, and the aluminum begins to solidify before it has fully filled the die, and the casting is scrapped. The cooling system is therefore designed to maintain a uniform temperature throughout the entire process. Once casting is complete, robotic systems extract the part, trim the excess metal, and send the component on for quality control. The result is not simply faster production. By replacing dozens of welded elements with a single casting, the Giga press makes the vehicle lighter, stronger, and more rigid, while simultaneously reducing production time, assembly complexity, and the need for manual labor. Today, Giga casting is no longer exclusive to Tesla. General Motors, Hyundai, Volvo, and Chinese manufacturers are investing billions in their own casting systems. One Chinese manufacturer has already invested in a machine with a capacity of 16,000 tons. But whilst everyone else is trying to catch up with Tesla, the company is preparing to leap so far ahead that the entire industry may be forced to reconsider its very notion of what is possible. Musk's next target is a 50,000-ton Giga press. When he first mentioned that figure, the initial reaction was predictable. How could a machine of that size even exist? Where would it be housed? How long would installation take? And most importantly, how can a single press simultaneously produce structural components for 5 different vehicles at once? According to Musk, that is precisely the point. Once the 50,000-ton press is up and running, the factory will move at a speed that a human being physically cannot track. Every stage, injecting the molten aluminum, cooling the die, extracting the finished casting will be carried out in a fully automated mode without interruption. A single production cycle will take around 5 seconds. An entire vehicle frame in the time it takes you to blink a few times. Musk described it this way: the line will move so quickly that people will physically be unable to approach it. This is not a car factory in the conventional sense. This is consumer electronics manufacturing, only instead of smartphones, vehicle frames come off the line. The fundamental principle of the 50,000-ton press is similar to previous versions. The difference lies in the scale and precision of every step. Aluminium, both primary and recycled from previous castings, is loaded into the furnace and melted at approximately 850 degrees Celsius. After surface impurities have been removed, the liquid metal travels through heated pipelines to a second sealed holding furnace, where it is maintained between 750 and 850 degrees, always ready for the next cycle. The space inside the holding furnace is filled with nitrogen. This prevents the molten aluminum from reacting with oxygen and forming unwanted oxides. For additional purification, argon, a rotary degasser, and a silicon carbide filter are used to remove dissolved gases and particles larger than 25 microns. Only after all of this is the metal considered ready. Before each casting cycle, the die is coated with a thin layer of lubricant. A robotic arm applies approximately 35 milliliters of soya oil evenly across the entire surface, so that the finished part releases cleanly. A vacuum is then created to remove air, after which the molten aluminum enters the injection chamber. A plunger, lubricated with approximately 8 milliliters of oil before each shot, drives the metal into the die cavity with enormous force. After injection, the metal solidifies inside the die, and the red-hot casting is extracted at a temperature of around 400 degrees Celsius. It is immediately submerged in a cooling bath, where the temperature drops to approximately 50 degrees. This is not simply about speeding up the process. Rapid cooling eliminates a number of casting defects and improves the mechanical properties of the material. The die, meanwhile, cools to approximately 185 degrees, after which a robotic system cleans every surface. The next cycle can begin within just 1 to 2 minutes. Excess aluminum is sent back to the melting furnace. Every finished casting undergoes X-ray inspection to verify its internal structure. Achieving this kind of speed is not simply a matter of building a larger machine. Tesla has developed an ultra-rapid cooling system, an intelligent die release mechanism, and an AI-based quality control system capable of inspecting every casting in real time. This combination of technologies has never previously existed in the automotive industry. And this is where the story becomes even more interesting. The 50,000-ton Giga press is not simply a new way of making vehicles. It is a reimagining of how factories operate. For the first time, automotive manufacturing is beginning to resemble the world of consumer electronics. Highly automated, incredibly fast, compact, and engineered to make maximum use of every square meter of floor space. A telling example: whilst the Model Y had around 200 major structural components, the Cybercab has approximately 80. This is not an evolution of manufacturing, it is a complete redesign from the ground up. For more than a century, vehicles were assembled from hundreds of individual parts joined by welds, bolts, brackets, and rivets. Each such joint is a potential point of metal fatigue or long-term wear. Tesla is moving in the opposite direction. A significant portion of the Cybercab's structure is intended to exist as a single monolithic casting. The advantages extend far beyond simplified manufacturing. A more unified construction provides greater rigidity, eliminates numerous potential failure points, and allows the chassis to behave as a single continuous element rather than a collection of joined parts. This delivers real-world benefits, from improved ride comfort and handling to more predictable energy absorption in a collision. And in a future where vehicles must drive themselves, this kind of structural uniformity could prove to be one of the key engineering advantages. But Tesla is not stopping at the Giga press. The next bottleneck the company has set its sights on is the paint shop. Painting a vehicle is one of the most expensive, energy-intensive, and time-consuming stages of production. Rather than speeding it up, Tesla appears to be asking a far more radical question. What if the paint shop isn't needed at all? According to Tesla's patents, the body panels of the Cybercab may be produced with color built directly into the material during the forming process. The color would appear at the moment the panel is created, with no separate painting stages required. It is worth noting that the latest production versions of the Cybercab appear noticeably glossier than the early matte prototypes, hinting that the idea is moving towards realization. If this comes to pass, the implications will be enormous. Paint shops occupy vast amounts of floor space, consume enormous quantities of energy, and add cost and complexity to every vehicle produced. Eliminating that entire stage means not just saving time, but fundamentally simplifying production and reducing the cost of the factory itself. Everything described in this video is not science fiction, nor is it some distant future. This is a manufacturing strategy that is unfolding right now, and if you're interested in following how global industry is changing in real time, subscribe to the channel and give it a like. The best is yet to come.